August 8, 1918, 4:20 a.m. German frontline positions, Morlancourt sector, 3 miles east of Amiens, France. Hauptmann Friedrich von Brixen of the 109th Infantry Regiment, 13th Division, stood in the forward observation post, scanning the pre-dawn mist through his periscope. Von Brixen was a veteran of Verdun and the Somme, holder of the Iron Cross First Class, and had survived 3 years of Western Front warfare by understanding artillery patterns. The British would telegraph their attacks with days of bombardment, but this morning the silence was complete. No preliminary barrage, no wire-cutting fire, nothing but fog and the distant rumble that von Brixen initially dismissed as British supply trucks. Then the barrage began. Not the usual hours-long preparation, but a sudden, devastating wall of fire that struck German positions at 4:20 a.m. precisely. Von Brixen pressed against the dugout wall as shells screamed overhead. But something else was coming through the mist, a sound he'd heard before at Cambrai 8 months earlier. The mechanical growl of tank engines. Not a handful of machines, but what sounded like dozens. Von Brixen grabbed his field telephone to report tanks advancing, but the line was dead, cut by the sudden barrage. What von Brixen didn't know, what no German officer would understand until 3 p.m. that afternoon, was that 414 Mark V heavy tanks and 96 Whippet light tanks were advancing across a 15-mile front in the largest concentrated tank assault in military history, and that the German army's defensive doctrine, designed to counter tanks with artillery, would collapse in 11 hours of fighting that would shatter 6 German divisions and force Erich Ludendorff to conclude that Germany had lost the war. German assessment of tank warfare following Cambrai represented logical military thinking based on observed performance. The November 20th, 1917 Battle of Cambrai had demonstrated both tank potential and limitations. British forces deployed 476 tanks in a surprise attack that penetrated 5 miles into German lines within hours, the deepest advance since 1914. But German counterattacks had recaptured most lost ground within 2 weeks, destroying or capturing 179 British tanks in the process. Ludendorff's General Headquarters staff analyzed Cambrai extensively through December 1917 and January 1918. Their findings, distributed to all German armies in a February 1918 directive titled The Tank in Attack and Defense, concluded that tanks represented a tactical challenge, not a strategic threat. The assessment identified specific vulnerabilities. Tanks were slow, mechanically unreliable, blind in closed hatches, vulnerable to artillery fire, and required infantry support to consolidate gains. Most critically, German analysis emphasized that well-trained artillery crews with direct-fire field guns could destroy tanks at ranges exceeding the tank's ability to return effective fire. The German 77mm field gun, firing armor-piercing rounds at flat trajectory, could penetrate Mark IV tank armor at 400 yards. German defensive doctrine, revised following Cambrai, emphasized forward deployment of field artillery in concealed positions with interlocking fields of fire. Battery commanders received specific training in anti-tank gunnery through spring 1918. The directive specified that each infantry division should position at least 2 batteries of 77mm guns in advanced positions specifically to counter tank attacks. This doctrine reflected German understanding of British tank capabilities as demonstrated through 1917. The Mark IV tank, which comprised the bulk of British tank forces at Cambrai, had a maximum speed of 3.7 miles per hour, an operational range of 35 miles, and armor thickness of 12 millimeters, sufficient to stop machine gun fire but vulnerable to field artillery. More significantly, British tanks at Cambrai had attacked with preliminary bombardment that alerted German forces to the coming assault, allowing artillery redeployment and preparation of anti-tank defenses. Oberst Max Bauer, Chief of Staff of German Artillery, wrote in his March 1918 assessment, "The tank represents an attempt to restore tactical mobility through mechanical means. But mechanical mobility creates mechanical vulnerability. The tank's armor protects against small arms fire while creating a visible, slow-moving target for artillery. The English have developed a weapon that transforms their infantry into targets for our guns. This assessment guided German defensive preparations through summer 1918. German confidence extended beyond purely military assessment. Industrial analysis suggested Britain lacked production capacity for tank forces large enough to achieve strategic effect. German intelligence estimated British tank production at approximately 50 machines per month based on factory reports and prisoner interrogations. This suggested Britain could field perhaps 300 to 400 operational tanks across the entire Western Front, enough to support local attacks, but insufficient to achieve breakthrough on multiple sectors simultaneously. What German intelligence failed to detect was the transformation in British tank design, production, and doctrine occurring through spring and summer 1918. Unknown to Ludendorff's staff, British factories were producing an average of 120 tanks per month by June 1918. More significantly, they were producing the Mark V, a fundamentally improved design that addressed the mechanical and tactical limitations that had plagued earlier Marks. The Mark V heavy tank represented 3 years of industrial problem-solving by the British Tank Supply Department under Albert Gerald Stern, working with chief designer Major Walter Gordon Wilson. Wilson had served on the original Landships Committee in 1915, but recognized that the Mark I through Mark IV tanks, while demonstrating tactical potential at Cambrai and elsewhere, suffered from fundamental mechanical limitations that prevented sustained operations. The critical innovation was the Wilson epicyclic gearbox, developed through 1917 at the experimental facility in Lincoln. Previous British tanks required a crew of 8 because steering demanded 4 men operating individual track brakes, 2 drivers, each controlling 1 track, plus 2 gearsmen. The Mark IV could only turn by stopping 1 track while the other continued moving, a process requiring careful coordination and multiple crew members. Combat reports from Cambrai documented numerous instances where Mark IV tanks became separated from infantry support because the cumbersome steering system prevented the precise maneuvering necessary to maintain formation in broken terrain. Wilson's epicyclic gearbox, patented in January 1918, allowed a single driver to control both tracks through a standard steering wheel and gear lever. The system used planetary gears to vary power distribution between tracks, enabling controlled turns without stopping either track. This seemingly technical improvement transformed tank operations. A single driver could now steer the tank precisely, reducing crew requirements from 8 to 6 men and dramatically improving mechanical reliability. Field trials at Bovington Camp in March 1918 demonstrated that Mark V crews could maintain formation over mile-long advances, impossible with earlier Marks. The Ricardo engine provided the second critical improvement. Harry Ralph Ricardo, working at his engine research laboratory in Shoreham by Sea, redesigned the Daimler Knight engine that had powered the Mark IV. The original engine generated 105 horsepower, but overheated during sustained operations, causing numerous mechanical failures at Cambrai. Ricardo modified the cooling system, strengthened internal components, and improved fuel delivery, creating an engine that generated 150 horsepower with improved reliability. Testing in April 1918 showed the new engine could operate continuously for 8 hours, compared to the Mark IV's 3 to 4 hour maximum before overheating required shutdown. Metropolitan Carriage, Wagon and Finance Company in Birmingham, began Mark V production in January 1918 under the direction of Managing Director Dudley Docker. The company had produced Mark IV tanks since 1916, but required substantial retooling for the Mark V's improved design. Docker mobilized 2,300 workers, including 600 women who had replaced men conscripted for infantry service. The workforce operated in 2 12-hour shifts, producing components that were assembled in a sequential process requiring 14 days from initial steel cutting to completed tank. Production accelerated through spring 1918. January output, 15 tanks. February, 22 tanks. March, 34 tanks. April, 58 tanks. May, 87 tanks. June, 121 tanks. July, 145 tanks. By August 1st, Metropolitan had delivered 481 Mark V tanks to the Tank Corps Depot at Bovington, nearly matching total Mark IV production for all of 1917. William Foster and Company in Lincoln, the original builder of Mother, the prototype tank from 1915, produced an additional 200 Mark V tanks using parallel assembly methods. North British Locomotive Company in Glasgow contributed another 150 tanks by August. British tank production reached levels German intelligence considered impossible. 424 Mark V tanks delivered in the 3 months before Amiens, with production capacity still expanding. The Mark V male variant mounted 2 QF 6-pounder guns, 57 mm, in sponsons on each side, plus 4 Hotchkiss machine guns. The 6-pounder could penetrate German bunker construction at 300 yards and destroy German field guns before they could deploy for direct anti-tank fire. The female variant replaced the 6-pounders with 6 Vickers machine guns, designed to suppress German infantry and machine gun positions. Both variants carried 12 mm armor on front faces, 8 mm on sides, insufficient to stop 77 mm armor-piercing rounds, but enough to defeat German machine gun fire and shell splinters. But specifications alone didn't create the doctrine that would shatter German lines at Amiens, that required the intellectual work of Lieutenant Colonel John Frederick Charles Fuller, Chief of Staff of the Tank Corps, working with Brigadier General Hugh Ells. Fuller had written The Tactical Employment of Tanks in 1918 in February, circulated to all Tank Corps units. The document represented Fuller's analysis of Cambray's lessons and proposed a radical departure from previous tank employment. Fuller's doctrine emphasized concentration, surprise, and coordination. Previous attacks had distributed tanks along the entire front in direct support of infantry. Fuller argued for mass tank deployment on narrow fronts to achieve breakthrough, followed by rapid exploitation. The Mark V's improved reliability made sustained operations possible. The key was surprise. No preliminary bombardment to alert German artillery, tanks advancing behind a sudden creeping barrage that would suppress German forward positions during the critical first minutes when tanks were most vulnerable. British tank production through summer 1918 represented an industrial mobilization that German intelligence systematically underestimated. German intelligence estimates in July 1918 credited Britain with approximately 300 operational tanks across the Western Front. The actual number exceeded 800 tanks, with 414 Mark Vs allocated specifically to Fourth Army for the Amiens offensive. The German estimate was off by a factor of 3, a miscalculation comparable to British underestimation of German artillery ammunition production in 1914. Metropolitan Carriage employed 2,300 workers, producing tanks by July 1918, working 2 12-hour shifts. The workforce included 847 women, primarily in machining and assembly roles that had been exclusively male occupations before the war. The factory complex in Birmingham covered 14 acres and consumed 340 tons of armor plate per month, supplied by Vickers Steelworks in Sheffield. Each Mark V required 27 tons of steel, 4 tons of copper and brass for the engine and transmission, 200 pounds of rubber for track pads and seals, and 840 man-hours of skilled labor. The 3 companies together produced 145 Mark V tanks in July 1918 alone, approximately 3 times German intelligence estimates of total British monthly tank production. British tank production in the 6 months before Amiens, March through August 1918, totaled 632 Mark V tanks, plus 200 Mark V Star, extended version for carrying infantry, plus 170 Whippet medium tanks, a total of 1,002 armored vehicles in 6 months. The cost of this production revealed Britain's commitment to tank warfare. Each Mark V cost £5,620 in 1918 pounds, approximately £350,000 in 2025 values. The 414 Mark Vs deployed at Amiens represented £2.3 million, roughly equivalent to the cost of 12 destroyers or 230 fighter aircraft. The total investment in tanks for the Amiens offensive exceeded £2.6 million, not including crew training, fuel, ammunition, or support vehicles. British tank forces at Amiens consumed 850 tons of petrol, 189,000 gallons, during the battle's first 3 days. Each Mark V carried 90 gallons internal fuel, sufficient for approximately 35 miles of operation. Ammunition consumption matched fuel consumption in scale. Each Mark V male carried 332 rounds of 6-pounder ammunition and 6,272 rounds of machine gun ammunition. Total ammunition load for the tank force exceeded 3 million rounds of small arms ammunition and 69,000 rounds of 6-pounder ammunition. German defensive positions on August 8th included 144 77mm field guns in forward positions specifically positioned for anti-tank defense, according to the doctrine developed after Cambrai. German artillery doctrine specified that field guns in anti-tank roles should be positioned in concealed locations with clear fields of fire extending 600 to 800 yards across no man's land. Each gun could theoretically engage and destroy 3 to 4 tanks during an attack. What German doctrine failed to account for was the combination of surprise, concentration, and coordination that Fuller's doctrine created. The 414 Mark V tanks attacked across a 15-mile front in a single morning, approximately 28 tanks per mile of front. German field guns positioned for anti-tank defense faced not the dispersed tank attacks of Cambrai, where tanks advanced in groups of 5 to 10 machines, but waves of 20 to 30 tanks advancing simultaneously across sectors too wide for available German artillery to cover effectively. More critically, the lack of preliminary bombardment meant German artillery crews had no advance warning. At Cambrai, British bombardment had begun hours before tank attack, allowing German artillery to prepare firing positions and ammunition supply. At Amiens, German artillery crews were still in dugouts when British creeping barrage began at 4:20 a.m. By the time German gunners could man their weapons, British tanks were already breaking through forward positions, and German infantry in the front lines were either surrendering or retreating, leaving artillery positions exposed. August 8th, 1918, 4:20 a.m. British Fourth Army, under General Sir Henry Rawlinson, launched the attack across a 15-mile front east of Amiens. The opening barrage involved 2,070 guns firing on German positions without preliminary registration, meaning German forces had no indication of coming attack until shells began landing. Tank deployment followed Fuller's doctrine precisely. The Canadian Corps attacked with 108 Mark V tanks and 24 Whippets in support. The Australian Corps attacked with 216 Mark V tanks and 48 Whippets. British Third Corps attacked with 90 Mark V tanks and 24 Whippets. Total, 414 Mark V heavy tanks and 96 Whippet medium tanks, advancing in waves across the entire front. The German Second Army, commanded by General Georg von der Marwitz, held positions east of Amiens, with 6 divisions in the front line: 13th Division, 41st Division, 109th Division, 14th Bavarian Division, 117th Division, and 27th Division. German strength totaled approximately 45,000 infantry with 540 artillery pieces in support. At 4:20 a.m., British artillery began creeping barrage 200 yards ahead of advancing infantry. 3 minutes later, tanks crossed the start line and advanced into no man's land. German machine gun crews in forward positions opened fire as tanks became visible through the morning mist, but 7.92mm machine gun fire had no effect on tank armor. German infantry in forward trenches, subjected to creeping barrage and suddenly confronted with tanks emerging from the smoke, began surrendering in groups. By 5:30 a.m., first reports reached German divisional headquarters, indicating breakthrough on multiple sectors. The 13th Division reported tanks had penetrated forward positions and were advancing toward Moreuil. The 109th Division reported similar breakthrough near Harbonnières. The 41st Division's forward regiments had ceased reporting, later determined to have been overrun or surrounded. German artillery attempted to engage tanks, but faced impossible targeting conditions. Morning mist limited visibility to 300 yards. British creeping barrage was falling on German artillery positions, forcing crews to take cover during critical first minutes of attack. When German gunners attempted to engage tanks, they found targets appearing suddenly from smoke at ranges too close for effective engagement. Field guns required 200 to 300 yards distance to acquire, aim, and fire. Tanks were crossing that distance in less than 2 minutes, while their 6-pounder guns engaged German artillery positions from advancing positions. By 8 a.m., Canadian forces had advanced 2.5 miles, capturing Marcel Cave and Arges. Australian forces had advanced 3 miles, capturing Harbonnières and Bayonvillers. The 13th Division and 109th Division had effectively ceased to exist as combat formations, forward elements surrendered, headquarters overrun, artillery captured or destroyed. German divisional commanders requested permission to withdraw to prepared positions further east, but communication failures prevented coordinated response. The breakthrough continued through morning. By 11 a.m., Canadian tanks had advanced 5 miles, Australian tanks 6 miles. German reserve divisions attempting counterattack found themselves engaging British tanks that had already penetrated behind German artillery lines. The 14th Bavarian Reserve Division, moving forward to counterattack, encountered Whippet tanks that had penetrated 7 miles and were operating in German rear areas, disrupting communication lines and supply columns. The tactical situation by 1 p.m. revealed operational collapse unprecedented in Western Front warfare since 1914. British forces had advanced up to 7 miles on a 15-mile front in less than 9 hours. German defensive positions that had required months to construct had been penetrated and bypassed. Most significantly, German casualties included 12,000 prisoners captured during the first day, indicating not determined resistance and attrition but rapid collapse and surrender. Tank performance exceeded all previous demonstrations. Of 414 Mark V tanks committed, 373 were still operational by 1 p.m. Mechanical breakdowns: 29 tanks. Combat losses to German artillery: 12 tanks. The mechanical reliability that Wilson's epicyclic gearbox created meant that 90% of committed tanks remained operational after 9 hours of combat operations and advances of up to 7 miles. Impossible with Mark IV tanks at Cambrai, where 179 of 476 tanks, 38%, had been destroyed or broken down within the first day. German defensive doctrine predicated on destroying tanks with forward-deployed artillery had failed comprehensively. The 144 German 77mm field guns positioned specifically for anti-tank defense had been neutralized by combination of surprise, suppressive artillery fire, and overwhelming tank numbers. German artillery crews had been trained to engage tanks at 400 to 600 yards range with aimed fire. Instead, they faced 20 to 30 tanks emerging simultaneously from smoke at 200 yards range while under bombardment from British counter-battery fire. By 3 p.m., British forces had captured 8,000 German prisoners, 161 guns, and hundreds of machine guns. German divisional commanders reported that organized resistance had collapsed across most sectors, and that German infantry were surrendering to tanks in company and battalion-sized groups. The day's results shocked both sides. British Fourth Army had advanced 7 to 8 miles on the first day, matching or exceeding the total advance of the entire 141-day Somme. Offensive in 1916. German Second Army had suffered 27,000 casualties in less than 12 hours, including 12,000 captured. 6 German divisions had been effectively destroyed or rendered combat ineffective. British casualties totaled approximately 8,800, a favorable exchange ratio unprecedented in Western Front offensive operations. Erich Ludendorff received initial reports of the Amiens attack at 9:30 a.m. on August 8th at his headquarters in Spa, Belgium. The reports indicated serious breakthrough but didn't convey the scale of catastrophe unfolding. By noon, additional reports revealed the depth of penetration and the collapse of multiple divisions. By 3 p.m., Ludendorff understood that German Second Army had suffered operational defeat. Ludendorff's subsequent description of August 8th as the Black Day of the German Army appeared in his 1919 memoir, My War Memories, 1914 to 2000, 1918. The passage reveals his recognition that the defeat represented fundamental military transformation. August 8th was the Black Day of the German Army in the history of the war. This was the worst experience that I had to go through. Our war machine was no longer efficient. The troops had obviously lost their capacity for endurance under the enemy's concentrated artillery fire and tank attacks. The 8th of August put the decline of our fighting power beyond all doubt. The war must be ended. The immediate crisis was tactical: how to contain British breakthrough and prevent complete collapse of Second Army. Ludendorff ordered 6 reserve divisions to Second Army sector with instructions to establish new defensive line behind Somme River. But the strategic crisis was recognition that German defensive doctrine had failed against concentrated tank attacks supported by coordinated artillery and air power. German casualties on August 8th included not just the 27,000 casualties in Second Army, but revelation of collapsed morale. The 12,000 prisoners captured included entire companies and battalions that surrendered to tanks rather than attempting organized resistance. German officers reported that troops had panicked when confronted with massed tank attack and that attempts to rally resistance had failed. This represented unprecedented breakdown in German army discipline, suggesting that the psychological effect of tank attack exceeded the purely tactical effect. Post-battle German analysis, conducted through August and September 1918, attempted to explain the catastrophe and recommend improved anti-tank measures. The reports acknowledged multiple failures in German defensive doctrine. First, surprise had been complete. British forces achieved surprise through eliminating preliminary bombardment and moving tanks into position at night. German intelligence had detected no indication of coming offensive, despite concentration of 510 tanks in 4th Army sector. Second, concentration overwhelmed available anti-tank defenses. German doctrine allocated 2 batteries of field guns per division for anti-tank defense, 12 guns covering divisional front of approximately 2 to 3 miles. The British attacked with 28 tanks per mile of front, creating local superiority of 60 to 80 tanks against 12 guns. Third, coordination between British tanks, artillery, and infantry created conditions where German defensive response failed at each level. Creeping barrage suppressed German infantry during critical first minutes when tanks were most vulnerable. Tanks suppressed German machine gun positions and breached wire entanglements. Infantry following tanks exploited breaches before German reserves could counterattack. Fourth, and most significantly, the Mark V's mechanical reliability enabled sustained operations that prevented German defensive recovery. At Cambrai, mechanical failures had immobilized sufficient British tanks that German forces could restore position through counterattack. At Amiens, 90% of British tanks remained operational throughout the first day, meaning German forces faced continuous tank pressure across the entire front with no respite for reorganization. But these doctrinal modifications came too late to affect the war's outcome. Amiens demonstrated that concentrated tank attack, properly supported, could achieve breakthrough on a scale not seen since 1914. The demonstration convinced Allied High Command that similar operations could break German defensive lines across the front. Through August and September 1918, British, French, and American forces launched series of coordinated offensives, the 100 Days Offensive, that progressively pushed German forces back and captured thousands of prisoners whose morale had collapsed. The recognition arc was complete. Pre-war Cambrai, in November 1917. German confidence that artillery could counter tanks through forward deployment and trained crews. August 8, 1918. Catastrophic failure as concentration and surprise overwhelmed anti-tank defenses. August through September 1918. Desperate attempts to modify doctrine through depth, defense, and weapon concentration. November 1918. Recognition that industrial capacity, not tactical doctrine, had decided the war. General Hermann von Kuhl, Chief of Staff of Army Group Crown Prince Ruprecht, wrote in his 1920 memoir Der Weltkrieg 1914-1918, "The tank attacks of 1918, particularly Amiens on August 8th, demonstrated that defensive warfare predicated on machine gun and artillery had reached its limit. The English had developed through industrial means a weapon that restored tactical mobility. Our defensive doctrine, shaped by experiences of 1914 to 1917, proved inadequate against mass tank attacks supported by artillery and aircraft. We recognized too late that industrial capacity, not tactical doctrine, would determine the war's outcome. Ludendorff himself acknowledged in My War Memories that August 8th forced recognition Germany had lost. The 8th of August made clear to all of us that the war could no longer be won. Our divisions had not fought as they had fought at the Somme and in Flanders. The troops had obviously lost their capacity for endurance. The tactical success of the enemy's tanks had a demoralizing effect. British assessment vindicated Fuller's doctrine of concentration, surprise, and coordination. Major General J.F.C. Fuller wrote in his 1920 analysis, "Tanks in the Great War. Amiens demonstrated that the tank, properly employed in mass with supporting artillery and infantry, could restore mobility to warfare. The German defensive system, formidable against infantry assault and even against dispersed tank attacks, collapsed when confronted with tank attacks in density sufficient to overwhelm available anti-tank weapons." The lesson was clear. Industrial warfare demanded industrial solutions, and victory came to the side that could mobilize industrial capacity most effectively. The contrast with Cambrai revealed how British tank warfare evolved in 8 months. Cambrai, 476 tanks, preliminary bombardment, dispersed across 10-mile front, 47 tanks per mile. Achieved 5-mile penetration, but counterattacked and position restored. Amiens, 510 tanks, no preliminary bombardment, concentrated across 15-mile front, 34 tanks per mile. Achieved 8-mile penetration that led to operational breakthrough and progressive German withdrawal. August 8, 1918, represented culmination of industrial transformation that began in 1915 when the Landships Committee first proposed tracked armored vehicles. The transformation required 3 years of technical development, factory construction, workforce training, and doctrinal evolution. The Mark V tank that broke through German lines at Amiens embodied that transformation, but the tank alone wasn't sufficient. Industrial capacity to produce 800-plus tanks, logistics infrastructure to fuel and supply them, trained crews to operate them, artillery coordination to suppress defensive fire, and tactical doctrine to employ them in concentrated attacks. The entire system represented industrial warfare at a scale that made pre-war military doctrine obsolete. German defensive doctrine following Cambrai had been logical given observed tank performance and estimated British production capacity. The doctrine failed because British industrial mobilization exceeded German estimates and because British technical improvements, particularly Wilson's epicyclic gearbox and Ricardo's engine, created capabilities German doctrine didn't account for. The failure was fundamentally industrial. Germany couldn't produce tanks in quantities sufficient to counter Allied tank forces, couldn't produce anti-tank weapons in quantities sufficient to defend all threatened sectors, and couldn't develop countermeasures quickly enough to affect the war's outcome. By November 1918, British forces fielded 1,391 operational tanks, Mark V, Mark V Star, and Whippet combined. French forces fielded approximately 3,800 tanks, predominantly Renault FT light tanks, produced at rates exceeding 300 per month by fall 1918. American forces were beginning to receive tanks from French and British production. The combined Allied tank force exceeded 5,000 machines by armistice, creating offensive capacity that German defensive resources could not counter across the entire Western Front. German tank production, by contrast, totaled 20 A-7V tanks through the entire war. The A-7V, Germany's only indigenous tank design, weighed 30 tons, required crew of 18, and suffered mechanical reliability problems that limited operational employment. German industry, strained by blockade and resource shortages, lacked capacity to match Allied tank production while simultaneously maintaining artillery, ammunition production, aircraft production, and U-boat construction. The industrial competition was decided by November 1918. Allied productive capacity exceeded German capacity for response. The broader lesson transcended tank warfare specifically. World War I was decided by industrial capacity rather than tactical doctrine or operational art. The side that could mobilize industrial resources more effectively, produce war materials in greater quantities, sustain production through years of attrition, and innovate production methods faster than the enemy could respond, that side would win. Tanks represented one dimension of this industrial competition. Artillery ammunition production, machine gun production, aircraft production, chemical weapons production, each represented industrial capacity translated into military power. Captain J.F.C. Fuller, promoted to brigadier general after the war, reflected on Amiens in his 1923 work, The Reformation of War. August 8th demonstrated that industrial warfare had transformed fundamentally. The pre-war assumption that railways and machine guns would make defensive warfare dominant proved correct for 1914 to 1917. But industrial development didn't stop with defensive weapons. The tank represented industrial response to industrial stalemate, mechanical mobility to overcome mechanical firepower. The lesson wasn't that tanks had won the war, but that industrial capacity to produce and employ new weapons faster than the enemy could develop countermeasures would decide future conflicts. Post-war German military theorists, analyzing the defeat, emphasized that future warfare would be decided by industrial mobilization capacity. General Hans von Seeckt, who rebuilt the German army in the 1920s, wrote, "The Great War demonstrated that industrial nations at war compete on industrial terms. The side that can mobilize industrial resources more completely, innovate production methods more rapidly, and sustain production through years of consumption will prevail. Military doctrine must account for industrial realities. The tank represented one industrial solution to tactical problems. Future warfare will see continual competition between industrial innovation and tactical response, with victory to the side whose industrial capacity exceeds the enemy's capacity to counter." But in August 1918, these lessons were just emerging from the smoke and confusion of Amiens. What was clear to Ludendorff, watching his defensive doctrine collapse in 11 hours, was that something fundamental had changed. The war that was supposed to end by Christmas 1914 had instead transformed warfare itself. Professional armies trained in pre-war doctrine had been replaced by mass armies employing industrial weapons. Cavalry and offensive spirit had been replaced by tanks and artillery coordination. Individual skill and courage had been subordinated to industrial capacity and systematic organization. The Black Day of the German army wasn't just one day's tactical defeat. It was recognition that the 19th century's approach to warfare, professional armies, decisive battles, maneuver, and morale, had been superseded by 20th century industrial reality. The Mark V tanks that broke through at Amiens represented that reality in mechanical form. Not the triumph of tactical innovation, but the inexorable logic of industrial capacity applied to warfare. Germany hadn't lost because German soldiers fought poorly or German generals commanded incompetently. Germany lost because Allied industrial capacity, British tank production, French shell production, American reinforcements exceeded German capacity to respond. The mathematics of industrial warfare were absolute. Ludendorff's description of August 8th as the Black Day captured this recognition. Not black because of tactical defeat, the German army had suffered worse tactical defeats at Verdun and the Somme. Black because the defeat demonstrated that continued resistance was futile. Industrial capacity had decided the war. The only question remaining was how many more months of casualties would be required before Germany accepted inevitable defeat. 3 months later, on November 11th, 1918, Germany signed the armistice. The war that began with cavalry charges and offensive spirit ended with tanks, artillery barrages, and industrial exhaustion. The formula that had guided warfare for centuries, superior tactics, operational art, and fighting spirit producing victory, had been replaced by a new formula: industrial capacity times technological innovation times systematic organization equals military power. The Great War had been the laboratory where that formula was proven. August 8th, 1918 was the experiment that confirmed the result. Ludendorff's recognition came 11 hours too late to save German defensive positions at Amiens, 4 years too late to prevent Germany's defeat, but just in time to shape military thinking for the next war that industrial capacity would decide.